nag-end ka aning share screen. Sorry for the whiteboard. Okay, so can you see my screen? Kita rin niyo akong screen, no? Ang whiteboard.
Yes, sir.
Okay, sige. So, previously we have this equation of our J. Previously we have the equation of our J. It has three terms. So, now to look at terms akong J. And then it is equal to 1/2 of okay, na rin. So, si J is equal to this, right? We have m vx x1 over 2 plus the second term, which is your assignment, no? Ano eta, not n but eta, pi square over 4x1 minus the potential x1 over vx. So this is our expression of our j. So na-integrate na ito, no? J, take note, is an integral of the Lagrangian dt. And the resulting integral is we have these three terms, okay? And as you can see here, first term is not a function of eta, right? The first term is not a function of theta, not a function, not theta but eta, not a function of eta. Also this one, the third term is also not a function of eta. Ang function lang ni eta is only the second term, no? First and third term are not a function of eta. Okay? It's not a function of eta. So meaning ani, it is constant with respect to eta, no? So, nga nag-emphasize na ako nga ang first of third kay dili siya function sa eta. It's because what we need to do to this j is we need to derive this one, right? Same atong previous na itong example. If we derive j, okay, if we derive j, this is with respect to eta, okay? So take note we will vary the path, the path, we say vary is implication na is you derive the function j with respect to eta, okay? So we will vary the path by varying the eta, okay? So that you will get change in j. This is, take note, the change in j is somewhat you are going to derive the eta, no? Change in j with respect to eta, okay? So somewhat you will derive the j with respect to eta. So in this case, the change in j, okay, the delta j now, i-derive mo nimong eta, no? So meaning the first term and third term will vanish. Tama? Because derivative of the first term, since dili sa function sa eta, take note kaning delta j there is, this is a derivative with respect to eta here. Okay, so since you vary the path by changing the function eta. Okay, so derive the first, that's equal to 0. Derive the third term with respect to eta, that is also equal to 0. So ang may tabo, ang imo lang, ang naalang nga term is only the second term. So what's the derivative of eta here? Take note the derivative of eta. Nakoy nga ni, no? Derivative, ang mabili, no? Kay 0, nakoy 0 plus the change of this m vx eta square pi square over 4x1 tapos na ako'y minus 0. Okay? And since you will derive only this with respect to eta, so kaning uban kay constant lang isa, no? So na ako'y m vx pi square over 4x1, you will derive the eta squared. And what is the derivative of eta squared? That's equal to 2 times eta times the change in eta. So na ako'y m Vx pi square over 4x1 na ako'y 2 eta times the change of eta. Okay? Times the change of eta. Okay? 2 over 4 is just 1 half. So you can simplify this function. You can simplify this function into this. The delta j is equal to pi square mpx over 2 na lang, no? Because 2 over 4 is just 1 over 2. So, nakoy 2x1, nakoy eta, the change in eta. And unsa itong gibuhat ngayon na to, once we vary the j, you will set it to 0 to find the maximum or to find the extremum. So, tama, to find the extremum, you will set j equal to 0. So, what will happen? It means that your pi mvx over 2x1 eta, change in eta, must be equal to 0. Okay? So, as you can see here, kano saan mag-0 ni nga function, okay? Kano saan ni mag-0 nga function, it is when your eta, thus, your eta must be equal to 0. Na naman, kaning pi m vx over 2x1, di man siya ma-0, right? So, kano saan mag-0 ni nga function when your eta must be equal to 0. The delta n is not equal to 0, generally not equal to 0. So, ang may tabo, your eta must be equal to 0. So, from this, okay, uh, we prove that there will be no amplitude. Okay? Kaya nga to ang gi-assume ang good, no? Sa ang path sa imong particle is sinusoidal, right? So we assume that the path will be a sinusoidal katong or na ako'y straight line lang from 0 to x1. Okay? And ang problem na to, ang problem is proof that there will be no amplitude. Take note, the eta is your amplitude. If we recall, the y, the displacement y is equal to plus minus eta, cosine mo ito gamit? Cosine no or sine? Sine, sine. Sine pi vx t over x1. Okay? So in this case, we prove that your eta must be equal to 0. Okay? So the by principle of least action, dapat dili sinusoidal ang path but only a straight line from 0 to x1. So eta is 0. So we prove by Hamilton's principle. And by the way, cannot be this one cannot be 0. So isa ra gud ang mag-0, no? Only the eta cannot be 0. So therefore, to satisfy this equation, your eta must be equal to 0. Okay, so we prove by Hamilton's principle, variational principle. Okay, it suggests that oops, that the path represented is not a sinusoidal function. It's not a sinusoidal function represented. It represented by this equation only. X is equal to vxt. Kaning nga path, no? Kaning straight line nga path. Okay? So the path taken from 0 to x1 must be a straight line which has an equation equal to x equal to vx times t. Okay? So this will be the actual path. Okay? So this will be the actual path. Not the sinusoidal function of path. Not this one. Also not this one here. Okay, so the actual path or the true path will be this straight line from 0 to x1. Okay, so this will be the path now. Y is just equal to 0. Okay, because y is equal to 0 because your eta must be equal to 0. Okay, so yeah, so we prove now by Hamilton's principle, we prove that there will be no amplitude. Eta is equal to 0. Okay. Do you have any questions on this one? Kira, no? Wala may question, ani? Wala na, no? Sige. Let's continue. So, we are done actually with Hamilton's variational principle. So, unsay gibuhat gali sa i-summarize na to ang no? Sa Hamilton's variational principle. Unsay ang gibuhat, first is we have this equation L dt, and then kuhaon nimo sa usa ka specific nga system, kuhaon nimo iyahang Lagrangian, which is just equal to this, kinetic minus potential, put it in the integral, okay? Isulod mo sa integral, so makuha nimo ang j equal to some function t minus v dt, and then what will you do? Gitawag siya nga variational because you will vary the j. Okay, variation meaning you set the j, you take the derivative, okay? You take the derivative of j, okay, L dt, and then set it to 0, then solve for the unknown. Solve for the unknown one. If you set it to 0, solve for the unknown, you will get the, say, amplitude ba kayo mong ikuha, okay? And so on, okay? So that's the variational principle. Ako'y j, vary the j, meaning sa vary is take the derivative of j, set it to 0 to find the extremum, okay? To find the maximum point baka or minimum point sa imong path, okay? Sa imong path. Sa Feynman path integral, kung kadumdum mo, if you have an idea on Feynman path integral, Feynman path integral, it is actually equal to this, um, k, it is denoted by k, and it is also an integral of the exponent of I h bar times the integral of L dt. So, somewhat nga na siya form, no? Ako ang, oops, na by dx dala. Dx is the living measure and so on. So, in this case, napa ko some normalization constant dira. In this case, as you can see, the Feynman path integral is nasa term nga integral of LDT, no? Nasa integral of LDT. We call this one as S. Diri kay tawag na to nga J, no? So we call it one as pwede ko mogamit og J, or pwede po mogamit og S. Okay? So we call this one as principle of least action. Okay? So somewhat gagamit siya og katong gagamit ang final path integral o variational principle, Hamilton's variational principle nga kani integral of LDT. But take note, this equation is a quantum mechanical equation because of this h bar here. Okay? So once because nako h bar dira, meaning kani nga formulation is a quantum mechanics nga formulation, not in classical formulation. But ang nakanindot is gigamit ni Richard Feynman ang kaning kaning nga concept, okay? Kaning nga concept, Hamilton's variational principle, to get the sure path, okay? To ang gamiton mo galing no katong kung nabantayan nato ang path niya, there are many paths, okay? There are many paths, okay? There are many paths, but the sure path, not the sure path, but ang iyang actual nga path is straight line. So same ani no? Ang gibuhat sa integral is they sum all of the path, okay? This integral of exponent dx is gisum niya all of the paths from initial to final point using the concept of variational principle, okay? We call it as S, or principle of least action. So somewhat nagamit niya ang kaning term sa ato ang sa ato ang J, okay? J is equal to L Lagrangian times dt. Okay. Okay, so too much for that variational principle. We will move to another topic. We have these so-called generalized coordinates. Okay, generalized coordinates. We know there are aton hebalan is natay tulo ka coordinate system, no? Tulo ra ba? Or pat na ako'y Cartesian coordinate system, na ako'y plane polar coordinate system, na ako'y spherical coordinates, na ako'y cylindrical coordinates. In this case, infinite iyang coordinates, bisa kung saan coordinates ang gamiton, we call it as generalized coordinates. So, makita nato diri unsa ang pinaka nindot gamiton nga coordinates sa usa ka system. Okay? So, same sa like nakoy system, then okay ba nga mogamit ko og Cartesian? Okay ba nga mogamit ko og spherical, polar, or cylindrical coordinates? So, ikaw mamili, no? Kung unsay gusto ni or kung unsay mas best nga coordinate system na imong gamiton sa imong system. Okay, so let's first discuss generalized coordinates. So we know that coordinates are used to define the position in space of ensembles of particles. Okay, so if I have a particle, you have to describe that particle in space using coordinates, okay? Using coordinates, mapa-Cartesian baka, mapa-polar baka, mapa-cylindrical, and so on. Okay, so gamit ang coordinates, no? Coordinates are used to define or to describe, okay? To define or to describe the position of a particle in space, in space of an ensemble or ensemble, okay? Ensemble, para sa no? Meaning configuration of particles in your system, no? And then mo tong mo no? Depende kung unsa ka klase nga coordinate ang best nga gamiton ato nga system. Okay? Say for example, a pendulum. Okay? For example, ako pendulum. Consider the motion of a pendulum. Pinakasayon nga system is a pendulum. So itong pendulum gani na ako'y particle, the motion of a pendulum. So, na ako'y gani, no? In Cartesian plane, for example, in three dimension. Oops. Okay, so na ako'y x. This is my x. This is my y. And then this is my z. Okay, so na ako'y Cartesian coordinate system. In three dimension, I have a pendulum. Okay, so na ako'y mass. Mass. Then you connect it with a light string. Okay, connect it with the light string in an xy plane. Okay, butan ako sa xy plane. So I have the length of this string is r, and then the angle is theta from measured from the negative y-axis. Okay, it's measured from the negative y. So I have this theta here. Okay, so in this case there are two. Kung makita niyo na kung duha ka coordinate system nga akong gamit in terms of Cartesian x, y, z, or in terms of plane polar r and theta. So we can describe for a simple pendulum, we can describe madungo ko ni class. Madungo ko.
Yes, sir.
Kaya ko maputol ko ha, kaya murag basin mawala man ito. Okay. So we can describe the configuration or the ensemble of the pendulum, okay, by means of its position vectors. So by means of its position vector. Of course, no, mo atong pinakauna nga makuha, no? Asa malocate ang imuhang particle or imuhang mass m, okay? By means of its position. Because take note, once we know the position of our mass, we know everything like velocity, acceleration, and so on. Okay, so importante, first is makuha na to ang position vector sa imong particle in your system. Okay? So, ang position vectors ani is in terms of Cartesian na ko x, y, z, or in terms of polar, plane polar na ko r and theta. Okay? So, there are two conditions of constraints on which pendulum must adhere. Na ko'y constraints ani, meaning sa constraint, meaning we have to consider equations nga uh, nga na limitation yung mass asa siya nag-move, okay? Asa nag-move yung mass, so we call that as constraints. So, the two conditions, so lang taon na ko, ang pendulum na ko is moving in an xy plane, so there is no z motion, okay? There is no z motion of your pendulum. So there are two conditions of constraints. We call this one as equation of constraint, okay? Constraints, okay? To which pendulum must adhere. So na ako'y take note, galihok lang ako ang mass in an xy plane. So therefore, my z is equal to 0. Okay, tama? So this is my first constraint. This is my first constraint. And as you can see, based on the figure, constraint lang imuhang mass m, okay, sa kaniyang motion, no? Mag-swing lang siya paana, no? Sakto? So constraint siya sa imuhang r, no? So one equation of constraint is we have this r which is equal to square root of x squared plus y squared. Tama? Or you can also write this as r squared minus x squared plus y squared equal to 0. So again, there are two equation of constraints. Nakoy ka na, and then I have this equation for the radius. Because take note, si mass nimo is galihok lang siya at some radius r, no? So muna yang isa constraint, no? Muna isa na ka constraint. Galihok lang siya, dili siya free of with respect to your radius r, okay? With respect to your radius r. So I have two equation of constraints, z equals 0 and this radius is equal to r squared um, minus x squared plus y squared. If you have x, you can solve for y and z. Diba? If you have x here, if given is ang x, you can solve for the y because kabalo ka sa akong r, sakto? Kabalo ko sa akong r, so you can solve for y. Also, you can solve for z. Z is just equal to z is equal to z. So, in this case, mamili ka, nakoy duha ka buok nga coordinate system, no? In this case, mamili ka kung asa ang best nga coordinate system ang gamiton. Cartesian ba or plane polar? In this case, a better choice will be the arc length displacement or we will use the plane polar coordinates. Okay, so a better choice would be the arc length. So, getting arc length, arc length displacement. Oops. We have this S just equal to R times theta, no? Kaning kung tanaw sa drawing, the arc length is just this. The arc length is just, no? The arc length, okay? So, theta is the angular displacement while S is the linear displacement. Okay? While S is the linear displacement. So, this is the arc length, okay? R times theta. The important point here is that the pendulum really has 1 degree of freedom. 1 degree of freedom ra ba ang ako ang mass sa akong pendulum? Yes or no? What do you mean by degree of freedom? So, sa ito? Honest lang ka, ano? Important. The important point. Oops. Kaya to, no? Anong 1 na lang man? Okay? Anong 1 na lang man? The important point is that pendulum. So, unsa ka pag-ihap ang degrees of freedom, no? Really has 1 degrees of freedom. Tama na to, no? Nganong isa na lang man? Take note, I have two equation of constraints, okay? Na ako two equation of constraints, okay? Degrees of freedom. So how will you calculate the number of degrees of freedom? Wait lang. Take note, si mass is in 3 dimension, nasa sa 3 dimension nga space. So when we say 3 dimension, it has 3 degrees of freedom. Okay? Na ako'y 3 generally the mass has 3 degrees of freedom. Kung isa lang ka mass, so ga-move siya to x, to y, and to z, right? So I have 3 degrees of freedom. Independent motion. Sa imuhang mass has nakoy pila ka mong independent motion nakoy tulo. So that's why we call that one as degrees of freedom. Okay? So move siya along x, move siya along y, move siya along z. So if I have mass m, I have 3 degrees of freedom. Okay? But na ako'y gidungag na duha ka equation of constraints. We have z equals 0 and we have r squared minus x squared plus y squared. So what will happen to the degrees of freedom? Ang may tabo, instead nga 3 degrees of freedom, doon naman ko'y duha ka equation of constraints. Ang may tabo, isa na lang kabuok ang degrees of freedom sa imong pendulum. So kana lang, no? Number of freedom number of freedom minus number of equation of constraints, you will get the total degree of freedom ang nga nasa imong system. Okay? In this case, I have mass M, which has originally has 3 degrees of freedom, but I have two equation of constraints. Minusan ako duha, so isa na lang kabuk freedom ang naa sa imong system. So in this case, ang pendulum is isa lang kabuk iyahang degrees of freedom. Question is, unsa nang iyahang isa ka degrees of freedom? Okay, lantaw na to, no? R is fixed, right? Si R, radius is fixed. So, when you change the arc length, when you change the theta, the arc length will also change. So, in this case, 1 degree of freedom lang siya, and that degree of freedom is in terms of theta. Meaning, sa theta ra magbase ang motion sa imong pendulum. So, kung mag-change ang theta, mag-change po ang position sa imong pendulum. Sakto? So, isa lang kabuk degrees of freedom. Isa lang kabuk variable nga mag-vary sa imong system. In this case, ang mag-vary lang is only the theta. Okay, so this will be your variable. This will be your variable. Isa lang kabuk, no? Take note, R is not changing, right? Fix man imong R. That's why gitawag siya nga equation of constraints kay fix man imo ang motion, fix imo ang radius nga R. Tawag siya nga equation of constraints. That is fixed. R is not changing. R is not a variable. G is also not a variable, so that's why we call that one as equation of constraints. Okay? So, ano ba ito? 1 degree of freedom lang. 1 degree of freedom lang. Okay? And that 1 degree of freedom is just in terms of the theta. The variable na mag-change sa imo ang system is only the theta. Okay? So, kung saan pag-calculate sa gani? Degrees of freedom, sayon ra, no? Originally, na ako 3 degrees of freedom, I have two equations of constraints, minus lang mo, you will get the number of degrees of freedom nga sa imong system. Pangitaon din mo, unsa to nga variable nag-depende imong say displacement ka or what. And that in pendulum, only the theta will change. Okay? Only the theta will change. Okay? Now, in terms of in terms of in Cartesian coordinate, kung magamit ko Cartesian coordinate, isa ra gyapon yung degree of freedom, sakto ba? Ano isa ra man yung degree of freedom? Kay kung lang taon nimo R, kung lang taon nimo ning equation, no? Kung lang taon nato ning equation, ang mag-change lang ani actually is the x. Or you can do x or you can do y. Okay? Because when you change the x, y is fixed because r is radius is fixed. So masolve nimo ang y because of this equation here. Okay? So only the x ang mag-vary. Mag-vary ang x kay mo nanapod sa value automatic ang imong y. So independent man akong y sa x or independent akong x sa y. So ikaw mamili asa sa duha. It's either in terms of y lang ka or in terms of x. So isa lang 'yun, no? Isa lang ka book degree of freedom. Ang naaning pendulum na system. Okay? Kira? So, it can move only one way. So, meaning sa degree of freedom, no? It can move only one way and that way is along an arc of radius r and then the variable that will change is only the theta. So, there exists only a single independent coordinate variable. Independent coordinate variable. So, manawin no? Independent coordinate variable here is the theta. Independent variable is the theta. In this case, for Cartesian plane, ang independent variable is only the x. Because y, when you change the x, y is also changing po, no? Y is fixed because of this equation here. Okay? Y is depende sa imong value sa x. So, dependent imong y sa x. So, meaning y is not an independent variable. So, only the x ang independent variable. Okay? You can use x or you can use y. Same thing. Same ra gyapon ang answer. Okay? So, yeah. There is only a single independent coordinate necessary to depict the position or the position of your system, the configuration of your system. So, generalized coordinates is defined as this. So, nakoy mga coordinates nga no? we will define we will define generalized coordinates. Generalized coordinates are defined as generalized coordinates are any any collection of independent variable, coordinate. Okay, sorry, not variable, but I call this one as coordinate. And the generalized coordinate is denoted by this QI. Take note, if mo QI, any coordinate na siya, no? QI, it means pwede ka mag XYZ, pwede pa ka mag R theta phi, pwede po ka mag rho theta z, no? In cylindrical coordinates. So, this is a generalized coordinates. I call this one as QIs, okay? QIs. That just suffice. QIs that just suffice to, to specify unique to specify uniquely the configuration configuration of a system of particles. System of particles. Okay? So again, this QI, take note, si QI kay any coordinates na siya nga nasa imong system. It's either Cartesian, polar, or cylindrical coordinates. Okay? So I will denote the generalized as, I will denote that one as Q. Okay? So, sa specific na problem, i-denote din mo siya into, pwede ka mag XYZ, arrow theta, phi, and so on. Okay? The required number of generalized coordinates is equal to the system number of degrees of freedom. Okay? The, so, the required number oops, of generalized coordinates is just equal to the number of degrees of freedom. Take note of this. Equal to the system's number of degrees of freedom. So in this case, katong sama-sama yung gano'n, sa simple pendulum, I have 3 degrees of freedom. So supposedly na ako'y 3 pod ka generalized coordinates. But if na ako'y equation of constraints, then i-minus din mo tong ila ka number of equation of constraints ka nasa imong system, no? So kung free particle, then I have 3 degrees of freedom. Kung ako'y free particle, isa lang kabuk, I have 3 degrees of freedom. So therefore, na ako'y generalized coordinates na tulupod. Q1, Q2, Q3, or I'll denote that one as XYZ, R theta phi, or rho theta, or rho phi z in cylindrical coordinates. Okay? So take note, equal ang generalized coordinates sa iyahang number of degrees of freedom. Okay? Number of degrees of freedom. And kabalo na ta mo ihap, no? Tama ba? Kabalo ta mo ihap, pila ka book number of degrees of freedom ang nasa ako ang system. For example, uh, uh, nakoy pila ka book degrees of freedom ang duha ka particle. Nakoy mass 1 ug mass 2. Pila ka book degrees of freedom ang nasa imong system? Anyone? Nakoy two masses, no? Nakoy two masses in the space freely moving. M1 and M2 are freely moving in space. Question is, how many degrees of freedom are there in your system? Pila ka book?
Unom, sir.
Unom, yeah. Tama, no? Because, nakoy, yeah. Thank you, Juliana, no? Nakoy unom, no? M1 has 3 degrees of freedom plus M2, which also has 3 degrees of freedom. So, therefore, I have 6 generalized coordinates. Tama? Nakoy, the coordinates are, say, in Cartesian, nakoy x1, x2, hindi na lang x1 akong gamitin sa mga akong gamitin eh. Generalize na lang, no? Q1, QM1, QM2, Ah, dili siya. Sorry, akong butang wait. Q, di po Q1, Q2. Sige, butang to. Q1, Q2, Q3. And then, ang isa, akong M2 has coordinates Q1 prime, Q2 prime, and Q3 prime. So, I have pila ka buok degrees of freedom? 6. Also, I have 6 generalized coordinates. The Q1, Q2, Q3, the Q1 prime, Q2 prime, and Q3 prime. Okay? So, nakoy unong ka degrees of freedom. Next, kung nakoy system gyapon, do ka mass gyapon. Do ka mass M2 and M1, pero gi-connect na ko siya og rod. Okay? So, nakoy rod dira, no? With some radius r, with some distance r, the distance between M1 and M2 and r. So nakoy duha ka mass, tapos gibutangan nimo string. Okay? Question is how many degrees of freedom are there? So kani pila ni kabuok? Nakoy 6 degrees of freedom. 6. And take note ha, depende ang imong generalized coordinates is just equal to the number of degrees of freedom. Okay? The number of degrees of freedom. For kaning next na example, how many degrees of freedom are there? Pila na kabuok?
5, sir.
5 na lang, no? Nanong 5 na lang, Juliana, kay
Kay constraints man ang R. Constraints man sa di ko kalito ko. Sa mga na siya, sir.
okay.
Kanang, sa independent, dependent variable.
Okay, tama no, tama si Juliana no. Salamat Juliana no, naminaw si Juliana sa kuha pag ano. Thank you Juliana no. So I have originally I have 6 degrees of freedom, but you put one equation of constraint, so therefore there are 5 degrees of freedom ang nasa imong sorry, 5 degrees of freedom na lang ang naa sa imong system. Okay? So kana lang no, ihapon nimo pila ka buok ang degrees of freedom minus equation of pila ka buok equation of constraints ang nasa imong equation, ang nasa imong system, then you will get the degrees of freedom. And then take note, ang generalized coordinate nato is just equal to the number of degrees of freedom na nasa imong system. Okay? How about this? For example, I have 3 masses. Okay, nako 3 masses, no? M1, M2, M3. Okay? So, kung di na ko siya isumpay, kung di na ko sumpayan, I have 9 degrees of freedom, no? Sakto? So, na ako'y 9 degrees of freedom ang nasa imong system. But, kung ako siyang i-connect, na ako'y rad dira, for example, na ako'y rad po diri, and then na po ko'y rad dira. Pila na lang kabuok degrees of freedom ang nasa imong system? Juliana. Si Juliana lagi. Si Juliana lagi.
6, sir.
Okay, na ako'y 6. Anong na lang, no? 6 degrees of freedom. Sayon ra mag-ihap og degrees of freedom. Ang lisod is unsa ning unong ka coordinates ang naa sa imong system. Sayon ra magyapon, no? Sayon ra mag-identify what are those 6 coordinates, 6 independent coordinates ang nasa imong system. Okay? So, lantaw na to, no? How there are 6 degrees of freedom here, but question is, can you identify the 6 independent? Independent dapat siya, no? Ang generalized coordinate kay dapat independent ni siya nga mga coordinates. Can you identify the 6 independent coordinates nga nasa imong system? Okay, lantaw na to, no? 6 man, no? Ako na lang sang yes. Yes, Julius, yes.
Sir, nangingon ka for free particle kay
Yeah.
3 degrees of
Yeah.
freedom.
Yes.
Sa tanan na siya coordinate, sir?
Yes, that's correct. That's correct, Julius.
Apil sa polar coordinate,
Ano,
sir?
sa polar, kuan raman ka, 2 dimension raman ka, no? Sa polar kay 2 dimension naman ka, tama? So 2 degrees of freedom lang na siya. Okay? Kay ngano, naka equation of constraint in which ang imong equation of constraints is nakoy z is equal to 0. So 3 siya originally, but since since nako equation of constraint nga z equals 0, so duha na lang ka degrees of freedom ang imong particle. Imong free particle. Free particle man dapat siya, so free particle in 2 dimensions. So, nako 2 degrees of freedom, Julius. Kaya nga ba ito? Nako equation of constraint at around equation nga z equal to 0. Okay, Julius?
Okay, sir.
Sakto ra, no? So, in general, maglihok dapat imong free particle in 3 dimensions. Sakto? But, you said that in plane polar, so kung sa plane polar ka, nakaisa ka equation of constraint na dayo, the z equal to 0. So that's why nara siya sa xy plane maglihok to the right, to the left, upward, downward. So moral na yung motion sa imong particle. So 2 degrees of freedom na siya. Okay? Sige. Okay. Okay, balik na rin, no? At kanin ba itong ang example is kanilang balik ka sa isa ka example kanila. Example nga kani nakoy mass 1 and mass 2, then separated with nakoy rod. The length of this rod is r. Okay, pila kay ni kabuok degrees of freedom man nakoy 5 degrees of freedom. Okay, degrees of freedom. Okay. So the equation of constraints, kung saan ang equation of constraint ani? As you can see, if I let this in 3 dimensions, so napoy system nga ani, no? Napoy ako ang coordinate system is this. Yes. Okay. This one is no? This one. Okay. This is z, this is x, and then this is y, for example. Okay. Si mass 1 has a coordinate of x1, y1, okay. Nakoy coordinate nga x1, y1, z1. Okay. Si mass 2 has a coordinate of x2, y2, z2. No? So I have 6 coordinates originally, x1, y1, z1, x2, y2, z2. But nakoy isa ka equation of constraints which is this r. And this r can be solved using the distance formula. Sakto? Using the distance formula, nakoy dependent variable r, which is equal to the distance formula, and we know distance formula, right? R is just equal to nakoy x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 quantity square. So this is now this equation. This equation is my equation of constraints. Take note that later magamit na to ning equation of constraints later to solve like the Lagrange multiplier. So mogamit sa Lagrange multiplier mo gud kay mogamit ta og mga equation of constraints sa imong system. Okay? So dapat kabalo ta unsa ang mga equation of constraints ang nasa imong equation. Okay? Nasa imong system. So in this case, nakoy duha ka mas connect mo siya grad with some length r, then the equation of constraint is just this one. R is equal to square root of x2 minus x1, y2 minus y1 square plus z minus z1 square. Okay? So, as you can see, there are 5 degrees of freedom. Anong 5 degrees of freedom raman siya? Because of this. Say, when your x1 is given, y2 is given, y1 is given, z2 is given, z1 is given, si x2 is dependent variable siya because masolve nimo si x2 using this equation here. Tama ba? So, 5 lang dapat ang independent variables nimo because ang isa, mahimo na siyang independent variable. Any of this variable, no? Mahimo siyang dependent variable because of this equation of constraint. Okay? Kung wala ning equation, unom dapat imong degrees of freedom. Si x1, x2, x1, y1, z1, x2, y2, z2 are independent variables. But when you have an equation of constraint, 5 na lang ang independent variable, ang isa kay masolve nimo any of these numbers, any of these variables, masolve nimo using this equation of constraint. So that's why I have 5 degrees of freedom. So it's either x1, y1, z1, x2, y2. Then z2 is your dependent variable, or na ako'y y1, z1, x2, y2, z2, ang imong dependent variable is your x1. Okay? Imong dependent variable is your x1. So, lima ra ang imong independent variables. Ani nga equation. Okay. How about this? Kabalo ng tani, no? How about that? So, na ako'y example na ako'y triangle nga ni, no? So, okay, na ako'y M2, M1, and then M3. Say the coordinate here. So, gi-connect mo siya kani, and kani. Say L1, L2, and L3. M1 has a coordinate of x1, y1, z1. X2 has a coordinate of x2, y2, z2. X3 has a coordinate of M3 has a coordinate of x3, y3, z3. So I have 9. But na ako'y equation of constraints na tulo ka buok. Equations of constraints nga tulo ka buok, no? Tulo ka buok na ako'y L1 square or square root. Pwede ko mag-square root, no? Or pwede ko may ngani, no? L1 square equal to x3 minus x1 square plus y3 minus y1 square plus z2 minus z1 square. Na ako'y L2 square nga, ang akong L2 ay kani, no? Ako'y x3 minus x2 square plus y3 minus y2 square plus z2 minus z3. z3 minus z2 1 square. Ang last is we have L3. Hindi na ako makasulat ng L3. Oops. So, si L3, butang ako sa taas, no? L3 square equals x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 quantity square. These are the equations of constraints. Okay? These are the equation of okay? And then as I said, ako 3 equation of constraints, so I have 6 degrees of freedom. So unom lang kabuk independent variable. 3 variables here are dependent variable. Okay? So 6 degrees of freedom I have 6 independent variables. Okay, and 3 dependent variable. Okay, dependent variable ang nasa to ang variable ang nasa to ang system. Okay, so yes.
Sir, yun sir, wala pagkuha sir. Kanang L1 squared, mga L2 squared, L3 squared. Yun sir, na pagkuha sir.
Distance naman no? The distance between M1 and M2, sakto? Distance between M1 and M2, you have to use distance formula. Sakto? In 3 dimension. Okay? Distance formula in 3 dimension. Sakto ba? Sakto ra, Jay? Kaya ang L3 kay distance naman to sa between M1 and M2, no? So we'll use distance formula. Distance formula is just this equation here. Nakoy x3 minus x1. Position along x square, position along y. So that's distance formula.
Okay, sir.
Okay. Oops. Okay. Do you have any questions? Wala na, no? So, yeah, I guess yara at tataman lang sa, no? So this Friday, I will continue discussing this generalized coordinates, and we will also discuss what do you mean by holonomic and non-holonomic constraints. Okay, holonomic and non-holonomic holonomic and non-holonomic constraints. Okay, so I will discuss this one next meeting. Holonomic constraints. Yes,
Mag-exam ta sir sa midterm
yeah,
and unsa ang ano
mag-exam
si
ka sa
mag-exam
midterm.
ta unsang
Mm,
coverage. Apilon lag
yeah, apil lang nato kaning kutob sa ato ang mga ma-discuss. Yeah, tama Julius. Pero mag-exam pa kog isa no, mag-long quiz pa tag isa and then mag-midterm din ta. Sige lang, mag-schedule lang ko karong Friday siguro. Okay? Okay ra Julius. Schedule lang ta sa Friday.
Okay ra sir.
Kapit lang sa mga man. Kapit na ta. Kapit lang ta sa Lagrange equation. Dito na rin itong mga application sa na yung mga system. Solve lang to siya using Lagrange equation. Okay. Do you have any questions? Wala na? So, attendance at takajot. Oops.